All right, good morning, good afternoon, everybody, regardless of where you are. I'm Rob Baker, Director of Renewable and Alternative Energy at Alberta Innovates, and it's my pleasure today to moderate a webinar with Decentralized Energy Canada, being headed by Anouk Kendall. So for the next hour or so, we're going to have, I think, a lot of information change hands as we go through our process here. What I thought I would do is maybe start our conversation today, and I'll just check. Everybody can see the presentation on the screen? Yeah, good.
Yeah.
What I'll do is I'll give a bit of an introduction to Alberta Innovates for those of you who don't know us, and then do an introduction for Anouk. And probably within 10 minutes, we'll start the Decentralized Energy Canada presentation. All right. About Alberta Innovates, we're an organization of roughly 600 employees, including a lot of folks with advanced degrees. We encompass about 11 locations in the province. The largest locations are on the screen there: Vegreville, Devon, Edmonton, and Calgary. We have two subsidiaries, Innotech Alberta and Cipher Technologies. Over the last number of years, there's been some, I would say, rearrangements of how the organization has presented itself. And in its current form, we have an operating budget of about $250 million headed by the Alberta Innovates ecosystem. The value of our portfolio, and these are numbers from the previous year, we haven't compiled the current year numbers yet, is roughly about 1,300 projects, and the sectors I'll get into right away here, with a total portfolio of about $1.3 billion, so it's significant. And the value that Alberta Innovates brings into the system, we'll go into the next few minutes here, does include our subsidiaries and also our collaborator organizations, of which Decentralized Energy Canada is one of them. The role that we play is threefold. We've got a convener and connector role, and that's a role where we're spending a lot of time talking with people, putting together what our industry in many different areas is going to look like. We are a partner and a collaborator. And as you probably, for those of you who know us, the biggest probably outward function you see is our funder service, of which is $250 million a year, pardon me. This probably does a really nice job of encapsulating the type of work that we take on. Typically, our technology readiness level is between 3 and 7, which would be the center part of what you see up here. It's this is a slightly different way of looking at the way that we approach our projects. At the very beginning, typically it's post-secondary research or someone coming up with a really good idea. We look at small and medium enterprises for venture development and technology development. And in those areas, it would probably be between the ideating and the establishing components. What we do also is look at large and major companies, both for collaboration and for funding, because these good ideas can come out of anywhere. And so as you can see, and the very, very simplistic, I would say, animation that we have here, from a good idea, which is what does flight look like, right to putting people into orbit or possibly on other planets. We haven't done that one yet, but maybe that's something we should be looking into. The 5 major areas that we have, I would say, a stake in the ground in are from a strategy position, entrepreneurial ecosystem development, and artificial intelligence, which is manifesting itself in many different ways, not only on the calculation side and the development side, but also on how it could affect our ability to deliver resources from an electricity or an energy side. Focus areas are in digital health, clean resource technologies, which is going to be the focus of today's discussion, and smart agriculture. It's hard to untangle projects that might be across any of these 5 sections, but we highlight them because in areas, there's some areas which definitely have a particular area of interest for the money that's being funded. Over the next couple of slides here, I'll just quickly go through some of the highlights over the last year. We've launched our Hydrogen Center of Excellence, hydrogen being a low emission way of maybe doing a replacement on some of the energy systems that we have out there right now. Water for Life invested in water and climate change solutions, obviously a huge issue. If you live in Calgary this week and if you're taking dirt baths, then that probably is something of interest to you. Of course, it's not anything that we would fund. In terms of a scale-up accelerator, we've raised about $150 million over this past year. We have networks that have, I would say, a significant expertise of 7,400 across the province here. And in terms of some of the initiatives we've looked at, there's about 25 of them in terms of the R&I economy development. Again, getting into some of the items which are going to be innovative for Alberta, and the focus here is to take on projects which will diversify the economy, bring good ideas to light, and make things better for us in the province here. We do have digital health solutions which have increased dramatically, pharmaceutical innovations, and we have ethics initiatives which celebrates users within a fairly large international domain. Again, here we have more agricultural funding, chronic wasting disease research, which is obvious in a place like Alberta where we have a vast landmass and a lot of wildlife, taking into account how we're going to deal with issues like that. And then looking at how we involve our subsidiaries, Innotech and CFR, in the development of things like R&D in hydrogen, or reducing GHGs, where we are a strong partner with Emissions Reduction Alberta, and looking at things like pipeline coating. How are we going to start moving hydrogen through pipes, and where we might have thought initially that moving hydrogen through existing natural gas pipes would work. Unfortunately, for many different reasons, that's not the case. And so we're trying out some new ideas here in terms of getting delivery of innovation to market. For those of you who did join us at Inventures in Calgary in May, thank you for coming. We're setting up already for next year, and we've got the new BMO Center as our new home for that particular party of innovation. Very specifically for today, we are partners. Alberta Innovates is partners with Decentralized Energy Canada, and thankfully so. We enjoy working with Anouk and her team. We are happy that they are one of the leaders in the access hub for the industry. One of the major roles that Decentralized Energy Canada is playing outside of any affiliations that are out there right now is that there is a tremendous puzzle of things that we're trying to disconnect and reconnect as we go through the energy transition. And having somebody that can take a higher level look as we assemble all these puzzle pieces is important. And it does speak to all of the things that we've taken into account in the energy systems to date, the clean, efficient, resilient, and affordable operation of them, and tries to reimagine them in a new world, which include things like the materials, the equipment fabrication, and the circular economy. To that end, Anouk is going to take us on a little bit of a venture today. She has deep experience in the industry. She has been piloting DEC through the energy transition. She's got tremendous background, which is very helpful. As we've gone through the energy transition, we've appreciated fresh eyes and new approaches, but we also kind of rely very heavily on the deep experience that comes from people that have been in the industry. And her work not only spans Canada, but also across the international community, which provides more credibility for the types of things that we're doing here today and going forward. She'll be providing a current year industry overview in her presentation. We'll be looking at some of the things that have changed in the past year, things like microgrids and innovation developments, and what we could be expecting as we go forward. Don't forget to attend the energy forum that's coming up. And one last comment is, I got the thumbs up there. One last comment is, for any questions that you have, please put them in the chat bar. And what we'll do, come to the end of the presentation, I'll start calling out some of the questions that come in, and we'll get Anouk and team to answer. So without further ado, what I'm going to do is bring on the presentation. Just bear with me for a moment. And all right, Anouk, can you see the screen? All right. And I can't hear you. Oh, hang on.
Perfect.
There it is.
What I didn't know is that once I was unmuted, if I mute myself again, you need the host to allow you to unmute again. So sorry. Can you hear me?
Sure can.
Super. Thank you. Thanks, Rob. This is fun. It's always fun to have a Zoom technical thing on Friday. Thanks for the intro. Good presentation too. That was good on Alberta Innovates. I enjoyed that. Thanks. And yes, we've been partnering with Alberta Innovates now for 21 years. And we were actually founded by the Alberta Research Council. Back in 2002, the Alberta Research Council had a working session in Calgary at the Calgary Chamber of Commerce to determine whether Alberta needed an industry association focused on distributed energy, and it was a unanimous yes. And I signed up for the grueling task of after the organizing committee and business plan task force, I signed up for the grueling task of the founding president, and it sure has been a journey. So today, what we're going to do, and every year, as part of our relationship with Alberta Innovates, is we give an industry overview, and it used to be an internal presentation, but we're now going a bit broader. It's useful information for everyone. It is not a technical presentation. It's more the bigger picture and a framework for opportunities. So this presentation, everyone has varying levels of understanding of what this industry is like, but everyone should walk away with something new that they didn't know before. It's not Alberta focused, but it does have some Alberta perspectives. As I said, we were originally founded as an Alberta Industry Association, but within 6 months we went national because in order to build momentum, you needed to join forces with other provinces and territories in Canada that were doing work on net metering and net billing and standard offer programs, which was Northwest Territories, BC, Nova Scotia, Ontario. So going national early was very strategic on our part. But one thing you're going to realize as we go through the presentation is there is not enough support for data collection and data analysis in this industry right now. So doing an industry overview is very difficult when you can't have a finger on the pulse of how many decentralized energy systems are installed, at what capacity, how many microgrids have been built across Canada. So I'll go through the bigger picture. The big message here is there is massive opportunity for innovation, especially in the electrical engineering, computer science, and communications side of things. So we'll jump to the first slide, the first slide actually shows the agenda of what we're talking about today. So I'll go through what has changed. Why are we having this conversation? Why can't we just carry on doing things the way we've done it since 1874? So what has changed? What's making it more urgent today? What is decentralized energy? The burgeoning microgrid era, which is very exciting and again, full of opportunity. Notable innovators in this space. And then we'll talk a bit about the Energy Innovation Challenge that's been launched and our Decentralized Energy Forum 2024. not 2023. Sorry, I've just caught that. Okay, next slide. I always have this slide, and I was going to take it out. And then I thought, no, I'm not going to take it out, because it really is the anchor and the grounding information that we need to understand what has changed and why are things changing. And there's really 7 big drivers. There is a global commitment to reducing emissions. I think enough said on that. It's very prominent all over the world as an objective. Traditional electrical grid challenges. So the way we built electrical grids originally allowed energy to go from a generation station to over great distances to the communities and the end loads, which required a lot of, I mean, Alberta alone has 26,000 kilometers of transmission lines. And that worked for us. That worked really well for the energy systems that we had, kind of the late 1800s, early 1900s, all the way up until kind of the early 2000s. But there's some constraints on, you know, as the other trends like electrification and prosumers, as these other trends rise, that electrical grid is becoming pretty restrictive. And it's a very expensive asset to be playing around on. So, and performance is key there. So I think that's enough said on that. It served us very well, and there is a need for a backbone for transmission grids. It's just that the nature and the role it plays in the future is going to change. Rise of prosumers, this is very simply, there are more and more people, more and more customers that are producing their own energy. So whether that's the Walmarts, the IKEAs, the home, the individual home, people are choosing to integrate energy systems into their buildings or campuses, and they're becoming prosumers. They are consumers and producers. And that changes the game very much so. Digitalization of utilities, we have digital transformation that's unlocking $1.3 trillion for the electricity sector. Most of you have heard what's called the smart grid, and we'll go into some definitions in a little bit. It's all about optimization, automation. Instead of putting out an emergency alert and telling people not to cook or not to use so much water, it's automatically done when the sensors pick up that there is a problem or a challenge or a shortage in the infrastructure. And so that's, again, huge opportunity for innovators with digital and digitalization solutions. The cost of renewable energy and energy storage is plummeting. It's going down every single year by leaps and bounds. The type of technology being used in renewable energy and energy storage is advancing, progressing. Elephant in the room is number 6, extreme weather and natural disasters. We'll cover a couple of slides on this, but can't turn away from this. This is costing the world a lot, and there's more complications. It's not just the economic losses. So there's other ramifications to this that are driving changes in our energy systems and electrification of society. So electricity demand in Canada will be 1.6 to 2.1 times greater by 2050, and we'll need 2.2 to 3.4 times more capacity in terms of electricity generation to meet that demand. So, and I know it's not directly relevant, but the autonomous vehicle uses and generates around 4,000 gigabytes of data per day. And you wonder, why does that matter? Well, it's a huge amount, and data centers are huge power gluttons. So, you know, electrification, I believe it's 2% of the electricity in the world is now used for data centers. And that's going to go up and up and up the more data we use. So looking at how much data we use for our autonomous vehicles, et cetera, is really important if we're going to forecast how electrification is going to play a role. The next slide. I want to go back to the design of our system. So I was mentioning that things have changed. We built our transmission lines to support a certain energy design. And so in 1874, when the first power plant was built in Lethbridge in Alberta, it was coal. And that map on the left shows that, you know, It just gives you, this is not meant to be going into anything deeply, it's just a bigger picture. You look at where the coal mines are on that graph, and then you look at where that's the tools crossed over, and then the gray is where the coal-fired power plants are. They were completely co-located, which made sense because you have huge coal mines that require an awful lot of energy to get the coal out. You have refining and processing, and then it has to go through conveyor belts into the combustion system. And so it's very smart and very strategic to have. It's a huge operation. So it's smart to co-locate. And then that's why it was smart for us to develop transmission lines to send the electricity to the loads. On the right-hand side, by 2020, so from 1874, it wasn't until 2020 that Alberta's primary source of electricity was natural gas, which actually surprised me. I thought it was a bit earlier than that, but it was only 2020. And that map on the right from the Alberta Biodiversity Monitoring Institute shows the active wells as of 2024, which is a far more distributed resource. So if you're comparing that to where the coal mines are, and not all of those coal mines are active anymore because that was 2014. But it's just, the purpose is to show that resource distribution. So natural gas is a far more distributed or decentralized resource. So again, just keep in the back of your head the transmission lines. It's really one of the most important things in this presentation. But after a century of our energy systems, it's really not much has changed from the 1874 model. So if we go to the next, I'm going to dive a tiny bit deeper into this. Again, this is from the Alberta Biodiversity Monitoring Institute, that map on the left. It's really hard to see, but the blue blob at the top around Fort McMurray is industrial energy production. The blue blob at the bottom with the purple clusters in it is wind generation facilities. And then ABMI is actually going to try and change the color of that line there. The transmission lines are the yellow or green, however it shows up on your screen. They're just all over. And the reason they're all over is because they're trying to connect generation, clustered generation to all of our centers and loads and communities. And so if you take your eye to the right side of the screen, this is, again, a really important part of our message, the decentralized energy message. If you take coal, gas, diesel, nuclear, anything that's using a thermodynamic power plant, you put 100% of your coal, hunk of coal, into the power plant, you are immediately losing 2/3 of your hunk of coal through waste heat and inefficiencies within the conversion. So in the best case scenario, it's 44, and that's more of a gas powered plant. You've got 44% of your gas left. And in the worst case scenario, which is an older, actually some of our coal was down to 23%, but anyways, you could be left with 32% of your hunk of coal in a good scenario. That to me is a big problem. It's unsustainable. It's not the way you want to look at limited resources, and the use of limited resources is losing, 2/3 of it to waste heat right at the beginning of your energy process. Fascinating piece of information. The most efficient part of your process is transmission. So only 1 to 2% of your energy, your electricity, is lost through transmission. It's very, very efficient. It's very, very expensive. We'll get to that in a little bit. Distribution lines, you're looking at 4 to 6% loss. I put a conservative 4% in there. And then here's another opportunity. Once that electricity gets into your home, we don't know how much is lost. We do know that we're still AC/DCing. We're still going back and forth on alternating current and direct current. So, stoves, large appliances require DC. Computers require DC, but the smaller appliances require AC. And every time you convert from DC to AC, you're losing 4 to 6% of your energy. So, And it's not measured. And this is a very active part of Decentralized Energy Canada. There's a few companies, Unico Power, Arcus Power, even the Schneider Electrics, the larger companies of the world are working on sensors and data, like accessing data within the home so that we have a better understanding of this part of you've got, you're left with your 25-30% of your energy from that hunk of coal. You probably want to make the best use of it. So measuring it is required. I think that's, the lack of metering at the end there. And just a funny slide is the next one. I thought it was kind of a nerdy, but it was a good slide. Modeled our coffee maker on the thermodynamic power plants. Well, I know I'm laughing. I think that's very good. That's when you're really, really interested in building something cool that does something, but you're literally getting just an espresso out of your bag of beans. And next slide. So all of us have electricity bills, and not all of us take a look at our electricity bills in very much detail. Some of us do. Gordon Howell in Edmonton I think he's got back from maybe even earlier than 2007, 2003, he's got all his energy bills in a spreadsheet divided up into what was the price of electricity, how much was charged for distribution costs, how much is charged for transmission. And so when I started this, I think we were at 75% of your bill was electricity. I was trying to dig it up just before this, and I couldn't actually find one of the bills to just pop up here, but it was about 75%. Now 30% of your electricity bill is actual energy. And then there's admin, distribution, and transmission. And with the demand growing by doubling by 2050, these are costs we need to pay a lot of attention to and look at alternatives and solutions. How can we increase that original conversion efficiency so we're not losing so much of our resource? And it's not just about the efficiency, which there's other questions. You can have an inefficient system that's still affordable and still sustainable. But when you're digging up resources and they're intense resources that require processing, it's a different story. So the next slide. More expenses are coming because of natural disasters. So it is a rising trend. So Munich RE and Swiss RE annually report on the global economic losses, and they do it for their business purpose of insurance. So they're looking at the insured losses and paying a lot of attention to what the insured losses, but the red line is economic losses as total, and the blue is insured losses. So we're kind of $250 to $350 billion per year is becoming the norm globally for economic losses from natural disasters. And if you go to the next slide, the next slide is just, wildfires, thunderstorms, floods, winter storms, droughts, earthquakes, volcanic eruptions, tropical cyclones. Some of them are not Canadian relevant. Most of them are wildfires, thunderstorms, floods, winter storms, droughts. And we're all familiar with this, but we need to be more familiar with resiliency and how to integrate resiliency into our design to cope with this. And then the other thing we need to think about is the protection gap. So if you move to the next slide, that red line before that was the economic losses and the blue line was the insured losses. In Canada, 41% of the economic losses are unprotected. So there is no insurance to cover the rebuilding of those. So whether it's transmission lines, distribution lines, power plants, other sectors as well, there's 41%. So, and things are getting more intense. There's more frequent natural disasters. The protection gap is a presentation we're trying to secure at our conference in Whistler in November. I think it's going to become a more important conversation. We were just in the Caribbean in March in the Bahamas, and it's now becoming common to hear people saying, I don't even bother buying insurance, or I can't get insurance. A, I can't afford it. B, the insurance company won't give it to me. They're just not bothering anymore. And that's going to impact the cost of everything. So that's the happy slide done. And they're going to go into, so what's decentralized energy? What is decentralized energy? So on the next slide, we've got, it's thermal energy or electricity that's produced, managed, or stored close to load. So the very premise of decentralized energy is integrate your energy systems into the built environment, whether it's your community or a building or your industrial process or your commercial process. It's your university, your hospital campus. Is it just your home? Is it an entire community, your neighborhood? That is the premise of decentralized energy, is integrating your energy systems close to where you need it. And there's many benefits. So there's many benefits to it in cost, efficiency, reliability, resiliency. But we're just not quite there yet. We have a lot of activity in this space. There are a lot of terms being used out there, and Decentralized Energy Canada recently worked with the CSA group to develop the technical specification TS 11723, which is referenced at the bottom there. And if you go to the CSA group store, you can download a copy of the terminology that's used in the decentralized energy space. And I would say there's a lot of terms missing from there because, you know, in the standards development arena, a term has to be used for so long before it becomes an adopted term. So we're still kind of early days, and there's a lot of terms like virtual power plants and microgrids that are still not considered common parlance. So we have issues with that. When there's new terminology and it's not being accepted as standard, it causes communication problems and people don't understand what you're talking about. They don't have a standard definition to go to. So microgrids, mini grids, and nanogrids are commonly interchanged, which again causes problems. So that's just the definition. I kind of feel like it would be great to kind of stop and say, does anybody have any questions? But if you go to the next one, I do want to, in that mini grids, microgrids, nanogrids, everyone has heard of the smart grids. And I just want to get a clear distinguish between smart grids and those other three. So smart grids are the networks that adopt digital technologies and sensors to optimize the larger grid. So the transmission, and to some extent the distribution, but it's all working as one bigger, the smart grid is a bigger picture of our electricity infrastructure and how digital technologies are optimizing the performance of that bigger system. Three subsets of smart grids is microgrids, mini grids, and nanogrids. Microgrids are distribution connected. So they are connected to the distribution network. They are a cluster of generation, energy generation, storage, even loads that are within a set boundary. So like a community, so you can have a community microgrid, you could have a campus microgrid. It's multiple generation systems, energy storage, and multiple loads within one. And it can disconnect from the larger grid and run what's called island mode. And that would happen when the larger grid failure occurs or you have a brownout, and your microgrid can separate itself from that larger grid and operate fine, as long as that microgrid has been taken care of and maintained, and that you've got energy storage on site, whether that's hydrogen, natural gas tank, batteries, whatever your energy storage solution is. This is that resiliency that you're building in. And microgrids, I think, is the biggest place for opportunity right now. Mini grids are more on that rural, remote. They are off-grid systems, and they're more about rural industrial campuses or rural communities. And they're typically less than 15 megawatts, but they're generally not an urban, it doesn't really make any sense to go off-grid urban right now. And nanogrids are within a building. So it's having solar panels, electric vehicle charging, battery storage, natural gas, combined heat and power, all within one building, and it is off-grid. Nanogrid is technically off-grid. And so I just wanted to get some of those, something to note. Some standby and backup generators are configured to connect and disconnect from the grid during outages, but they're not microgrids. They're just backup generators. So they're not considered in the, they'd probably be considered an entity in the larger smart grid side of things. How can you have peakers or backup generators being used to support the smart grid infrastructure? So if you look at microgrids, and we're going to go to the next slide takes us to the US because we don't have this data. And I think this would be a fabulous project for Canada to work on. We do have microgrids, but we are not recording them. So this is the US Department of Energy's microgrid installations tool. And so there's a data set behind that you can download. And so utilities and any microgrid owners go through the US Department of Energy to register their microgrid. It gets vetted and then it gets uploaded into the data set and added to the map. And so this right now, this was the 2024, it was a live snapshot of the microgrid installations in the US. As you can see, California and Texas and New York are the busiest buzzing microgrid areas, networks of distributed. And so distributed energy resources, a very common term in North America for decentralized energy. So DERs is what they're called for short. So these microgrids are networks of DERs and loads that can connect, disconnect, and reconnect to your distribution grid. And it allows you to serve your local loads more reliably and more affordably. And then it also provides resiliency during larger system outages. Yeah, it's an interest. So they've got the interactive map of microgrid installations across the US. I think it's fantastic that they've done it, and we should just copy it and figure out places we can tweak this tool. I think it would be very powerful for our industry analysis and understanding our market opportunities in Canada. And if you go to the next slide, that networks, this distributed energy resources and loads, that interface is the interoperability interface, which has huge opportunity for predictive analytics, controls, automation, AI. This is probably the best microgrid visual by Cushing Terrell. It's hard to find visuals too to support presentations on this, but this is one of the best visuals you can get. It shows that you've got a connection to the larger grid, and it shows the diversity of energy systems you can have: natural gas, combined heat and power, cogen. You could have solar, you could have wind. You don't commonly have distribution connected wind, but it is possible. Electric vehicles there's an active space right now on vehicle to grid, or there's also pros and cons to it, but I'm still so surprised at how much juice an electric vehicle fully charged has. I mean, keep your house running for 4 to 6 days on more than just critical loads, which surprised me. But it also makes you think, well, that's interesting. You've got an on-site energy storage system in your car, which it makes you think outside the box. It makes you think about your energy a little bit differently, instead of just light switch on, light switch off, call NMAX or call EPCOR if something's wrong. I think, so this actually, the visual, and it's hard to find good visuals, but this is the best I can find. But a project that DEC is working on right now is value chain mapping exercise. Because traditionally, when you said where does your electricity come from? You'd say, well, you've got your coal miners, or you've got your gas companies, and those gas companies sell to the powered, unless you're Medicine Hat and you own the gas and you own the power. But typically, you understood who the players were. So you have the generation plant, and then that generation plant sells it to a retailer, and that retailer sells it to the household. It's very simple, but now it's not simple. You can be buying energy. Theoretically, you can be buying energy from the University of Calgary campus for a regional microgrid or for a microgrid. These are transactions that are coming soon, are happening in certain places, and it changes our whole value chain. Who do you see as the energy generator? Well, it's the same person as the consumer in some cases, but that consumer doesn't need all its power, so it's going to sell to someone else. It's a fascinating space, and I think the value chain mapping exercise, as we go through all the people in this industry and ask them, who are your customers? I think we're going to be really surprised at what we see at the end of this exercise. Customers are changing, suppliers are changing, the whole value chain and its supportive supply chain is changing. So well, I will keep you posted on where we get to with it. It's supposed to be done by October, so hopefully we'll have a video and some infographics and a report for you on the value chain mapping exercise. Next is just, this is kind of so I've been into this for 21, 22 years now. And no matter what energy system you look at, there are pros and cons. There are good things and there are bad things about it. And we are extremely naive to think that there is any source of energy that's not going to have any negative consequences. But I do think we need to have front and center in our head, you know, 3 questions that help us with decisions made today and how it's going to impact our efficiency, sustainability, resiliency, and affordability in energy. How much does your fuel cost? So that sounds very simple. Okay, so if you're using a resource, you're going to have to pay for that resource, like gas or coal or diesel or nuclear. You're going to have to pay for your fuel. If you're using wind and solar, you don't have to pay for it. There are other things you need to consider, but you don't have to pay for that fuel. What waste streams are being created during conversion of that fuel into energy, thermal or electrical, and the delivery of it? How much waste heat are you producing? How many volatile organic compounds, polyaromatic hydrocarbons, GHGs? What are the consequences and the waste streams of you producing energy from that? And then what is the human footprint of the full life cycle? And this is where renewables and hydrocarbons, they all have a human footprint. It's nice to say that your point source emissions from an electric vehicle are 0 compared to an internal combustion engine, but building that battery and building the equipment that allow you to have 0 point source emissions has a lot of emissions in its manufacturing and its processing. So I think we always have to have, and these are just 3. I mean, I'm sure there's probably 5 or 10 questions that we've got to ask. There's a bigger consequence to our energy systems than just what you see in front of you. And to have doubling this amount of electricity that we're going to need by 2050, these are questions we really need to be thinking about in a much broader, less of a profit driven, less of a how easy is it for us to do this. I mean, we do have to think about if we're going to do transmission lines and build out our transmission lines that they cost $1.5 to $3 million. Nowadays, it's more like $3 million per kilometer of transmission line. That's a very expensive asset, especially when you think that wildfires and extreme weather are compromising some of our assets. We've got to think about all these things as well. And I think just there are innovators in this space that are doing incredible things. They're taking risks. They're not getting the huge paychecks, to take home. They're actually innovating. They're entrepreneurs. They're taking risks to help us innovate solutions to some of our challenges. So the next slide has got an example. I actually have some of them that were on from last year, but most of them have doubled or tripled their investment. So Arcus Power is a predictive analytics member of ours in power management, and they've received $15 million in sustainable impact capital. Ayrton, which is distributed hydrogen production and hydrogen storage, is at just about 2 million now. They're an early startup, and they're in the kind of the early TRL phase. eZinc is now at 34 million. Open Energy 40 million. So eZinc is electrochemical technology using zinc metal. Open Energy was it's data optimization and using automation to improve the performance of your energy assets. Origami Energy's 98 million. That's a trading software for allowing the transactions we were talking about with the new value chain. And then Ping Things is now up to 7.7 million. They've been doing very well. Their analytics platform for utility sensor data too. So a lot of them, as you can see, more than half of those are focused on data, predictive analytics, SAS solutions or SaaS, the digital platforms for real-time data, energy trading. And so that to me is indicative of that opportunity. People are seeing that as a big opportunity. I think I'm speaking too slowly. The next slide is just about us. So Decentralized Energy Canada, we've been around for 21 years, federally incorporated, not-for-profit. Our vision is a mature, decentralized energy industry that empowers and enables the transition to a sustainable, resilient, and affordable energy future. Our mission is to challenge the status quo, create opportunities by convening, educating, and engaging. Our greatest asset is our network. We have a phenomenal network across Canada and globally. And we can activate that network either on a bigger, which is super fun when you do the Decentralized Energy Forum, and that's that bigger network engagement where magic happens because people didn't know they needed to know each other and they didn't know they should be working with each other. And they come up with some amazing things. Last year, a $7.5 million program on critical minerals and geothermal came out of Oxford University and the Rocky Mountain Institute being at our event. So now Montserrat is receiving $7.5 million of research and development for critical minerals and geothermal, which is fascinating. But sometimes we do very targeted. So parts of our network that need like data or energy storage or electric vehicle charging, we'll do, targeted networking to help people create new partners, build new projects. We help write curriculum for universities and colleges to help them keep up to speed with what industry is hiring for so that those new graduates come out with the skills that the industry needs. We have the next slide. We have 114 active members. We have a network of 11,800 in our network. And a lot of in our network, they have their own networks that we tap into too. So that's a conservative network number. We've got 21 years of business to business and business to customer engagement support. We're balanced. This is a very rare thing for a not-for-profit industry association. We have 65% of our revenue from private sector and 35% from government. So industry fee for service is about a third, events income is about a third, and then our memberships is only we're quite heavy on the innovator and entrepreneur members. So membership rates for our entrepreneurs is quite low, so we don't have a huge revenue from memberships. And then government program funding is 35%, and it's very rare to see that, but it gives us resiliency. It reduces our vulnerability. It means that we have other ways to make up for income to maintain our financial sustainability. If one of these, like COVID, there was no events revenue coming in, so our industry fee for service ramped up. Next slide is the most exciting thing happening with us right now is the Energy Innovation Challenge. And this is a 3-year program, $2.5 million program funded by Prairies Can and the City of Medicine Hat. The City of Medicine Hat is our host sponsor of the program. They will be choosing with DEC as the administrator of the program. Medicine Hat will be choosing up to 6 projects to fund to help strengthen their distribution grids. And so it's really, if you go to the next slide, they have challenge statements. I'm sorry, this is a really boring slide. It's a snapshot right from the Energy Innovation Challenge webpage. There are 2 things that Medicine Hat's looking at: grid decongestion at a customer level and grid decongestion at the system level. So at the customer level, we're looking at demand side management, some demand response as well, energy efficiency, looking at the energy density of systems. And then when you move to the system level, we're looking at that predictive modeling to help improve the performance of the distribution network, some innovative energy storage solutions that can be strategically located within the distribution network to optimize the system, energy aggregation, even talking to a few virtual power plant companies on what is a good business model for aggregating DERs in Medicine Hat, and then modeling the system. So we're very excited about it. We're working with some amazing people. Medicine Hat's extremely progressive. Their team is very knowledgeable. We're working with their distribution engineers, their legal, their communications. It's a very powerful team we're working with. And we're also, there's $1 million right now tagged for projects, up to 6 projects. And we're talking with others right now about boosting that, getting some more money into the project pot for demonstrations. And we see this as a long-term program for DEC that we can continue to replicate this and build on it. And I just have one more slide and then I'm done. So the next thing, so sorry, Robert. Decentralized Energy Forum, Whistler, is all about achieving energy resiliency. So everything I've talked about today, we are going to find experts from around the world, and a lot of them will be from Canada, but we'll be talking about demand response, workforce changes, technology breakthroughs. There's pitch competitions from innovators, sharing their new, and it's just a really good group of people. You feel safe talking about the challenges you have in the workplace. You find incredibly smart people that are creative solutions. They find a solution. It's a really exciting place to be, and you should be there. Okay, and then that's it for me. Thank you. My last slide is a thank you. Now, Rob, you have to unmute yourself, but maybe Karen has to unmute you. I know, it's a fiddle, isn't it? If Karen's still there, you have to unmute you, Robert. Well, I could keep talking. I see that there's some Q&As here. So while Rob's working out the unmute, unmute is the resource losses.
Here.
Oh, there you are.
Go ahead. Tell you what, because of our time, why don't we just go through the questions, Anouk, and just answer them one by one? That might be the most efficient way to do this.
Okay, that's great, and it's good. The resource losses slide is actually it's the thermodynamic power plants. It's thermal power plants. You're losing it to waste heat. About 60% is going through waste heat. It's not your line losses. Transmission line is the most efficient part of the entire system. You're only losing 1 to 2%, which is amazing. But it's because it's a bigger line, it's carrying more juice, it's more insulated. Distribution lines lose more because they're smaller. It is a generation loss. Okay, and reach out to us, Gino, if you want to have a chat with either Robert or I. Our email addresses are on websites. Yep. Why is the percentage of energy on the average power bill decreased to be only 30? Why is the percentage of energy on it has decreased to, that's because the delivery charges have gone up. So in 2009, you might have been paying, I don't know, 5 cents per kilowatt hour for your electricity. You're now paying, I can't remember, I have my thing right in front of me. You're probably paying 16 or 17 cents right now. So you're paying more for the electricity, but it's becoming a smaller part of your bill because transmission, distribution, rate riders, bulk access fees, local access fees, all these other delivery charges are on it. That's why the energy component of your bill is smaller and smaller and smaller, because delivery is more and more expensive. Why it will again, all of you reach out to us if you want to. Will decentralized energy reduce energy prices? Okay, well, good question, Gino, but in order to answer that question, we need to have more data about what happens with the energy systems in the house. So there is a big mystery over how much energy is lost within the house. What can you do with sensors within the house and automation? So big opportunity to learn more. But I can tell you, the $1.5 million to $3 million per kilometer of transmission line is a big price tag, and microgrids do not have transmission infrastructure involved with them. Do we not have the data because we don't have smart meters? No, it's bigger than that. It's more sensors and meters on actual physical loads. Like, how much is your fridge using it at any given time? How much is co-op's open air refrigeration using at any given time, which a lot of the commercial do have it because they're saving money by having meters and sensors on their loads within those buildings. How more effective would these initiatives be if Alberta and Saskatchewan governments were more supportive of clean energy? Yeah, well, yeah. Okay, so another elephant in the room is we have developed economies that are very reliant on multiple players in the economy. So a resource economy is a very complicated beast. So once you are paying people to discover resource reserves, and then you're paying people to extract it, you're paying people to refine it, there's a lot of people that rely on the economics of a resource economy. So I think there's some stresses on how do we make sure people are still taken care of, people still have jobs, people still have a good standard of living when we're dramatically changing the structure of our economy and what it relies on. Keith, do you think the biggest driver for adopting new ideas? What do you think is the biggest driver for adopting new distributed energy resource? I think it's resiliency. I actually think it is people knowing that the lights will stay on in extreme weather or in a winter storm, that you're not going to freeze to death. I think it's resiliency, protection, and I think it's power. It's empowering the customer to make better decisions. Right now, we just rely on our utility to make all of the decisions for ourselves. And utilities are going to play a huge role in the future of decentralized energy and microgrids. They're going to be the transactional master. They're going to be the people saying, hey, you can trade with Karen next door right now. There's a huge opportunity for them. But it's, you know, it's once we get past this fear of change and understand that there's so much opportunity, and it's going to be better for us in that resiliency, affordability, reliability side of things. Anonymous, what's your opinion on making infrastructure cost part of our provincial taxes? And having our electricity bills focus on usage. Right. Okay, well, I like the idea of rewarding people that are, you know, that are using demand side management, energy efficiency, and taking it seriously. I like the idea of rewards. And that's a complicated one, anonymous attendee. We can reach out to us and let's have a deeper discussion, because I think there's a lot of opportunity to think about things like that. Rewards or penalties, increases. Or do we still have time for any more? This is most questions we've ever had. And then is the increase in distribution charge a direct result of no, I've already answered that. So that's just because delivery charges are going up. And you get, so I think Alberta had, don't quote me on this, I think the wildfires last year had costed $1 billion for Alberta, including a substantial amount of power infrastructure. So it's everything. We've got, you know, costs. We've everything, the three things. We've designed our energy system on coal, which is a very centralized thing, and now we have distributed, and we still got these expensive centralized infrastructure supporting it. And then we've got extreme weather that's costing a lot of money every year to our infrastructure. And then we've got the increase in electrification, which is increasing the amount of electricity we need and when we need it. So it's all culminating, and it's all leading to a reinvention of our energy system, rewrite it right from the bottom up. Don't strand your assets, don't waste what you've already got, but think strategically over time on how we're going to transition. Keith, 2020, another Keith Hirsch. 2025 forecast at 70% electricity will be generated by cogen. Oh, okay. They also predict all gas-fired plants will be CCUS by 2025. Oh, I don't have an answer for you, Keith, there. I think there's one thing about natural gas that Alberta needs to really hold on to. It's a local resource. If we can figure out that, as you said, cogen and combined cycle, you're getting up to 75, sometimes 85% efficiency if you are matching thermal load to those systems. The reason we're losing 60% from the thermal plants is because we're not using that waste heat. It's just going up. If we can figure out a way to get up to that 75, 85% efficiency on natural gas, cogen, and combined cycle, I think it would be amazing. Then you're using local resources in an efficient way, attracting more industry. CCUS, I don't have a big opinion on that. I don't have enough knowledge in the science behind CCUS and its sustainability and longevity. And I think we're probably, Rob, are we?
I
We're
think
at 104.
this speaks well that we still have the majority of folks on the line, even after our time here, because this is an engaging topic and people have a variety of views on this. And the biggest thing is that we're on this talking about it, and be able to provide a forum by which people can bring this out, latest information, assembling these pieces again. Any other questions from anybody else on the line here?
I think Crystal.
I think we've hit. Oh, hold on. Maybe another one's come in. Here we go. Keith, go ahead, Anouk.
Which one is it? And
It's the
Crystal has sent me some too through WhatsApp. There's another 4 over on the other, but Keith's was since current plans. Oh, I've answered them all. Oh, good. That was very efficient of me. Since current plans indicate natural gas will be the primary fuel for Alberta. How this? Yeah, LNG is not my. I'm sorry, I can't answer that either, Keith. That's more of a hydrocarbon and on the oil and gas side of things. I don't have an answer for you on that. I could find someone. Will LNG exports impact power prices in Alberta? I do not have an answer for you. That's not my area of expertise. So, but you and I can talk offline, Keith, and I can connect you to people who will have that answer.
You want to touch on the WhatsApp questions as well?
Oh, Crystal said I already answered them, which was.
Oh, there we go. Okay.
Yeah,
You are efficient. Yeah.
Yeah, I think just the parting words for me is it's a changing. I don't think many people, there are some people that really, really get it and see it as opportunities. And those are the innovators that are getting like the 25 million of investment dollars because they are able to communicate what the opportunity is for energy systems in the future. And I think just the message we need to get out much wider is that energy relationship and the value chain is changing so much. It changes the way we do business right at the very core. And it brings you as a community member into the picture in a much more powerful way.
Absolutely.
Yeah. And cool innovations coming out. So yeah, I think when we're in Whistler, we're gonna see a few new companies hit our radar. Those are always really exciting. Like I remember Arcus when they became members, they were pre-revenue. Within 5 years, they had 11 million. They've now got 15 million. They're working all over the world on predictive analytics and really saving money for people by optimizing their interface with the grid. It's very exciting.
Well, very good. I appreciate everybody who's joined today to listen to another yet inspired conversation regarding where we're going with this entire thing. I appreciate it. Again, as Anouk has mentioned, please reach out. You've got our contact information after the fact. If questions occur to you after the fact, let's address them and look forward to seeing all of you in Whistler.
Yay!
All right. Have a great weekend, everyone.
Yeah, you too.
All right.
Okay, bye.
Bye for now.